Kalispera I learned after 4 p.m. or something like this, but this is my only Greek, and it's not my only, but at that time. I wanted to give you an introduction which is relatively short about what we are doing in Stuttgart, and you know, I'm not engineer, I'm only chemist, but natural scientist, and we come now a little bit from the meta level to the technological things which are influencing the future, hopefully, and I can explain it at the examples for the past. Now, let's say, the items will be the short introduction, general trends in coating technology, which is giving the insight what will be most probably in the future, like we see it, materials development and painting technology. This is the technical part, and then I will give short summary. So, as Andreas already mentioned, I'm for a long time, long term in coatings. And I think this is a sake now for nearly 40 years in the Research Institute for Coatings and Pigments, which was then put to the Fraunhofer IPA in Stuttgart. I will say some words. And since 7 years, I'm also deputy director of this institute, which is relatively big. Fraunhofer, eventually you know, he was famous for his, let's say, telescopes and the lines, and also to say a little bit not so nice things for stealing technological ideas and bringing them to Germany. And he was, but this is the decisive thing, he was successful in science and in entrepreneurial activities. And that is the reason why we have this namesake. So Fraunhofer Society in Germany in 2023 is divided over Germany, but we have also subsidiaries, not in Greece, but in other parts of the world. And we are situated in Stuttgart, so to speak, in the middle of Baden-Württemberg, near the big companies like Porsche, Daimler, Bosch, and so on. And so this is clear that there is mechanical engineering an important thing. But as you can imagine, we are also now amidst the transformation activities to digitization and all the other, let's say, things where many people say this is the future. Let's say artificial intelligence, we discussed about this today too much. Eventually some numbers, 3 billion euros of sales per year. This is not so a small amount, and 30,000 employees and 75 institutes. Fraunhofer Society and Fraunhofer IPA is one of it. And as you can see, what is green is Fraunhofer IPA. This is the biggest in Stuttgart. And where the circles are, this is what is at the moment under my responsibility, where we have our labs and things like this. Let's say around 100 people. So you see here factory of the future, all these nice buzzwords, artificial intelligence, energy, mobility, new mobility, electromobility, batteries, production of the future. We had Industry 4.0, now they are talking about 4.1, 4.25, and all that things, life science, biointelligence systems, all items what you need to get funding, public funding, and also to be, let's say, a lighthouse for the industry. And I don't want to read this because these are more or less the directorates. We have network production, resource efficient production, intelligent automation and clean room technology in Fraunhofer IPA, here medical and biotechnology, and then manufacturing and process engineering. And this is under my responsibility, surface engineering. And it's not only organic coatings, it's also galvanic coatings and these smart materials and things like this. What I will focus today is mostly on this process chain, like coming from the raw materials to painting technology and then coating. And you see here all these, let's say, sub processes which are relevant, like dispersion of pigments or rheology, coloration. We will do this, and it goes up to the finished coating to say something about the, let's say, durability, functionality, and all these things. And we are doing this with around 60 persons in an interdisciplinary and systemic research approach. And we are relatively strongly customer-oriented, so this means industry. Simulation and resource efficiency were always an issue in coating, and I will today focus not so much on construction coating, or let's say all these things like painting of walls or things, you know, there is also some approaches using drones or things like this. We also did this, but I want to stress how important these simulation and resource efficiency activities are for industrial painting. Industrial paint and coating, this is important because this makes the value, and it's always like a factor of 5 or even more. When you have 1 kilogram of paint, which costs, I don't know, 3 euros, then the finished product, the surface technology with all capital and things, is 15 euros. Now, the general trends in coating technology, which I put together already some years ago, and we always try to let's say, to continue it. I would say that organic coatings, especially galvanic, we can discuss, but will in general gain in importance. We had this today, thin layer and protection for 10, 30, 50 years. Let's say if the transport of electricity, not under the earth, but in the atmosphere, a tower must, or tower for wind mill, but metal tower in Germany is supposed to stay for 50 years now without repair. Yeah? And that is all about infrastructure, and you can read it more quickly than I can say it, so I will go through this. We say mega trend that we must use our sources, our resources in a respectful and sustainable manner. We were discussing this. Surfaces and interfaces are the contact point to the user. You know, everything here is, or mostly everything is coated. And multifunctionalization is a driver of the technology. And you see here, this is not the metro map of Athens, it's a roadmap of technological trends. I will not go too deep in it. And what you can see here is, let's say, we also discussed here the urbanization. Then the answer must be for the industry that we have ultra efficiency. So in principle, everything what goes in a production process must be reused at the end of the life and things like this. So only in that way we can make the basis for the future generations. I think there is no alternative. We have only this earth, and as you know, after, let's say, 5 months, we also depleted the resources for 1 year. So this is another thing, and this is in our name. Automation processes are important, and this is Industry 4.0 for painting. You see here this chair, you see the robot, and the idea is to make everything automatically, that the robot sees what it is, he scans this thing, yeah. Then there is in the cloud, I will show it, I will not have too much time later. In the cloud you see the calculation of the path, because most of the industrial processes are painting by spray painting, another issue. Then it sprays the chair, and then the chair is more or less finished. Then quality control is important, and the system sees that, for example, the film build is not enough on these parts, and then it recalculates what has to be done to spray it. It resprays, and then later on it's finished, you know. And that is the idea to do it, and we had a big project to do it. Or to develop this concept. Individualization or personalization, and by this a late design or production differentiation are in the trend. You can see this with, let's say, additive manufacturing or things like this, but color is one of the most important things for differentiation. And this leads to massive changes in production concepts and layouts of our production sites, especially in case of late or ultra-late personalizing. What is also the thing that classical coating processes in printing are becoming more and more similar. What you see here is not what you think. This is a droplet which is free-flowing, and you saw the satellite. You see also here a satellite, and this is the film already existing on the surface. This goes relatively slow, and now you see this is taken with a high-speed camera. The droplet goes on the surface, then it comes again. And this is done by this piezo distributor, and it's not a distributed spray. The droplets all have, in principle, the same size with all the benefits and the odds. And this is the same in principle with a bubble jet printer. And the bubble jet printer are now only, by the way, discussed with, let's say, microplastics and all that things. And we must get rid of the distributed spray, which we have overspray and all that things, so we call it overspray-free painting. We have the same with powder coating, because powder coating is by nature microplastics. And we could now watch this film. I will not do it, but you believe me, we built this facility, this small facility for painting these aluminium parts, and also making pre-treatment, and then by trans-ebb process, let's say sprayless powder coating, we were able to coat this. And so what is this? Coating facilities will become more and more process-oriented. At the moment, the situation is that normally you have one big coating, let's say, coating line at the end of the production, but they will be more and more like this, where locally the production process are made in a small scale. Yeah, now one of the fads of so to speak, of materials, multifunctionality, and this is looking for the nature. What does nature? And this is all the self-cleaning, or changing of color and all the things. And this will be a driver. And we were also intensively discussing today about the issue of, let's say, Green Deal. Frau von der Leyen is a promoter of this, but I think this is relatively, there is not too many alternatives, and material development will have to concentrate on the substitution of components to preserve the actual performance of coatings, because we came from natural materials, and the natural materials were not sufficient in quality and things like this, in persistence. So then it was changed to, let's say, to chemical processes and things like this, whereas the nature also produces it by chemical processes. We discussed this before. And now we see, okay, we must go more to these processes back. And then that is what we also discussed here intensively. Finally, at the moment in our economic system, monetary factors count, the net present value or something like this. And this is often in controversy to the environmental things. And this is thesis zero. This is Carl Valentin. He was one of, let's say, comedian or Niels Bohr. They say prognoses are different, especially if they refer to the future. Yeah. And I think this is what we also had before, because, we never know, and especially as, let's say, a technician or a natural scientist, we are not natural philosophers, and we don't know. We influence the future, but we don't know it. And for me, I was polymer chemist. I'm still polymer chemist. I'm also more or less, let's say, lawyer now in my elder ages in the institute. But, it's really hurting me, all these microplastic discussions. Yeah. it's clear if we produce amounts of tons of plastics, and then somewhere it must go. And this is the same with coatings, by the way. But the good thing of coatings is this is not the mass, you know. So I will give some examples and go relatively quickly through it. What we are doing, we were working very intensively on, let's say, on the stabilization of particles. Everybody does this, but we use this approach of, and this is now a little bit technical, lower critical solution temperature. We urge that polymers to lay down on the surface, and then this is one of the, let's say, steric stability mechanisms. And we go now, if you heat it for a certain temperature difference, you know, these polymers collapse on the surface. You have two phases in a solution, and then they collapse on a solid ground, and these are the particles. We can see this, and this is then a measure or a method for, let's say, floating of pigments in the coatings during the curing. Yeah, and this is called stratification process. So we make these different strata, like in stratosphere. We can prove this. You see here more particles, here less. I could explain this all. The other thing is, because we have also many nano presentations now, or talking about nano corrosion protection is very important, because you see here the surface is not flat if you look in the detail, and then if you have smaller particles, they have a bigger surface, and so they can also reach the cavity of the surface. And we got for, let's say, not the Nobel Prize, but let's say the European Coating Show Prize some years before. Water uptake reversibility is also one of the methods we are using, you know, measuring how the coating takes up water, and this is one of the methods to reduce exposition, natural exposition, because the water content is important for the stability. Now, more like I said, smart effects, you know, here you see smart, you can illuminate from the back, for example, this plastic part, and this is coated, and this is, let's say, intrinsically laser marked. But with the laser destroys the pigment, so then you can see from the back with different illuminations what is in. I think in the cars this is normal, but the thing is now in cars things change dramatically, and screens are now the standard. And what you see here is one of that also, let's say, FETs, but you can cover a car, let's say, with screens outside. The question is how long it takes. But here you see, for example, by temperature change, the color which changes. And I think there is some potential to use this also. Another thing which is for environmental purposes very versatile, we were working intensively, is photocatalysis as an instrument for self-cleaning surfaces. And the thing is that titanium dioxide is the active species, and together with sunlight, it makes the dust, the dirt, yeah, depending on what it is, especially the organic material, oxidizes it, and then it can be washed away with water. So if somebody tells you this is inside, I'm relatively reluctant. It works at shower places or where you have water, but it will not work very good. Now my presentation. Okay, thanks to, yeah, very good. But the other thing is this is making or destroying the organic material by photocatalysis, or to destroy also nitrogen oxides in tunnels and things like this with artificial light. Now, painting technology, how do we bring material on the surface? I already showed something. powder coatings, for example, to use powder coatings with materials, to modify powder coatings with non-conductive but heat conductive materials, not electrically conductive but heat conductive. We made an intensive study, a whole project, and okay, if we could use diamonds, this would be the best, but it's too expensive. So there are not so many materials which are a good thermal conductor but not electric conductor, because we want to save energy and heat the materials up in a shorter time. Let's say powder coating needs 150, 160 degrees like this. Yeah. So then the other thing is this, what I showed you with the droplets before. I hope this was impressive to make these overspray-free applications for cars, for things like this. You have the application, the droplet, the point, the line, and you must make the area. And that is one challenge. We did this for several parts. There is also the possibility to do it on three-dimensional shapes, but it's not so easy. You have to calculate it. You need artificial intelligence, because you have to look at this being like reality. So now, again, shortly, this explanation for what I showed before, because everything of this calculation for the chair must happen in the cloud, you know. And so the cloud must be very active with the system, and also the digitization path, optimization of painting, where you can see what is astonishing if you calculate this, and this is simulation, this is not an animation, you know. It's physically based simulation. You see, if you do it, let's say by the machine, by this calculation, by this self-paint process, there will be on some parts, let's say, spray patterns you wouldn't do as a painter. Yeah, what is also a very, very important thing always for liquid paints is the viscosity, and optimizing and calculating viscosity, because this in technical areas makes leveling and flow, and here is also the calculation depending on the viscosity, how this, let's say, how it builds the surface when droplets come on the surface, and then when it cures, then you will see it shrinks down, and it will level, but these leveling and these things will stay, and we have now a closed approach from droplet to leveling to paint processes, multi-layer systems, and so on, to calculate this, and this is one of the, let's say, prospects and advantages of digitization. This I cannot show, thanks God, because this is now beyond my possibilities. But what we did here is, you know, and this is a highly technological activity. Also, da muss ich jetzt da raus. Because, you know, if you have, especially in planes or for lightweight constructions, carbon fiber materials, you know, and they are in contact, for example, with aluminium in planes, then there is corrosion problem, and this was a project to paint the edges of that carbon fiber reinforced materials and to protect it, and then to cure it with UV. But I cannot go forward now because this technique doesn't allow me to do it. We make these, let's say, landscape things like this is only the ideas for automotive coatings, but for each and every field in the coatings industry, you can have these wishes, the kaleidoscope of wishes and the ideas, and I think this is the future to do it, but all under the regimen of sustainability, and also using more or less, I mentioned, under the regimen of Green Deal, then let's say the the thing of biomaterials, and you read already the summary. Coating technology, cross-functional, new concepts are necessary for all kinds in human societies. And there is also some problem because we have mission research programs, and then these basic technologies which are necessary for our society are not so much in fat, and coatings are important. Science must be challenged by transfer of knowledge to practice. I think this is important. And we have many sponsors here, BMBF, our Ministry of Research, and the Ministry of Industry, and so on, and the co-workers who did that. I'm sorry that I also needed 5 minutes more, but I'm finished for now. Thanks.